Communication, we're going to talk about mass and volume and how we measure them and what they can be used for. By the end of this, we should be able to use the terms appropriately, use the units that are applicable. We should know how to measure the mass of an object and know how to find the volume two different ways. One, by calculation for a regular shaped object, like a sphere or a cube, something like that. That's what a regular shaped object is. I know you guys. Who's taken geometry before? Who's taking? Oh, so you guys are all taking geometry?
We took it.
Yo, you're done. Awesome. So you guys know about volume of stuff. A little bit. Okay. And should also know volume by displacement, which is actually more common than by calculation, but we'll probably do both. So first off, volume is how much space an object takes up. Okay? So volume, we can measure it for a regular shaped object, something like a cylinder, a cube, a sphere, a triagonal pyramid, something like that. You can calculate it. You know, remember volumes equal to like length times width times height? You guys sound familiar?
Yeah.
Okay. Or 4/3 pi r cubed.
No.
The volume of a sphere. Pi r squared h for a cylinder. I know you guys did this. I know you're geometry teachers. I do.
She's not here.
Who? Oh yeah, she moved to Saratoga.
I know.
And also, the way we're going to do it more often in chemistry is by displacement. Water displacement. You guys know what displace means? What does that mean? Close. To move. So it can be getting rid of, but like a lot of times you talk about displacement, like if there's a natural disaster, there's a lot of people that are displaced. Like when Hurricane Katrina. I know actually you guys were really young when Katrina happened, right? When Katrina happened, they had a ton of people displaced from New Orleans, and they sent them all over the country because it was such a disaster. And I'll talk about why later. But so displace just means to move or to send away. So volume, don't have to write this down. Do not write this down. Just look up here. So volume of a sphere, 4/3 pi r cubed. That's volume by calculation. Of a rectangular prism, it's length times width times height. Okay? So if you had a 3x2x5 regular object, it would be about 30 meters cubed. Okay? That's geometry. Displacement. Now, Archimedes, crazy guy, great scientist. I'll play you this video, okay? I'm going to pause it, though. So, volume by displacement is when an object is placed in a liquid or water, the volume will rise by the volume of that object. So, just a quick little side note about how to read a graduated cylinder. This is a picture of a meniscus. So a meniscus is the curvature that the water forms in a container. So what happens is you're supposed to read the volume from the bottom of the meniscus. So see how it curves down? So this would be 20.0 milliliters right here. Right on the, see how that's right at the bottom? That's how we read it. So 20.0 milliliters, right from the bottom there. So don't read it from the top, always the bottom. That's how things are made. So volume by displacement, you can calculate the volume if you know the initial volume of water and the final volume of water. So record this. So the key thing here is that the volume of the object is equal to the final volume minus the initial volume. Okay? So if you look here, I want you guys to look at this. If you can't see, you can come up a little closer. I want you guys, starting with an initial volume of water, we added a goldfish to the water. I know Terrence doesn't like goldfish, but we did. He didn't have to touch it, though. So I want you guys to try to calculate the volume of this fish right now. Okay? All right. So here I have my volume of water. I'm going to abbreviate volume of H2O. Now here I have my volume of water plus the fish. Right? So what happens? How do I calculate it, Jess?
Add, subtract.
Yes. So subtract what?
It'd be negative. You can't subtract.
Well, hold on. Well, other way. Other way. So I want to know the volume of the fish. Right? So I know my volume of H2O plus the fish. What happens if I subtract the volume of the H2O? What am I left with? No, what am I left with? Volume of what? What?
The fish.
Volume of the fish.
Which is 2.
Well, hold on. So what's my starting volume? 32. What's my final volume here? 38. We'll call them milliliters. So what's my volume of the fish? 6 milliliters. Taste is trying to trick you. Don't, you guys can't just rely on other people. You guys got to rely on yourself. See, that's a good lesson, Tejas. Tell you. Don't believe everything everybody tells you. All right, so that's it.